Okay, today's lesson is on factoring differences of squares. Hopefully through the activity we've just done, you've discovered this, that a squared minus b squared can be factored as the product of a plus b times a minus b. A very simple example would be x squared minus 9. Because x squared is a perfect square, and because 9 is a perfect square, and because they're connected with a minus sign, I can factor this as the product of x plus 3 times x minus 3. And again, this x is the square root of x squared, the square root of 9 is 3. So those numbers show up in the factorization. What I have in blue here is the least amount of notes that you'll need to have for this lesson. In addition to this list that tells us when we can use them, when we can factor this way, we'll also work a bunch of examples. This, however, is what's crucial. Okay, we can factor a difference of squares when we have two terms, a squared, b squared, or x squared, and 9. You'll notice that one of the terms is quadratic. It could also be to a fourth power even, or a sixth. Anyway, and the other is typically a constant term. Both of these terms have to be constants, and they have to be connected with a negative sign. Let's work some problems. Okay, in this first situation, we can factor here. We notice that we've got two terms. The first is quadratic, the second is constant, and let's see. So we can factor this. Well, we know the first terms are going to be the square root of m. The square root of m squared. So each of them are going to be m. The second terms are going to be the square root of 64, which is 8. One of them is plus, the other is minus. The order doesn't really matter. I typically write the plus first because I like positives instead of negatives, but either one is correct. Okay, b is a little more complicated, but we'll see that it's still a difference of squares. A difference, meaning we have a minus sign, and let's see if these are perfect squares. 16 is 4 squared, and y squared is y squared. 81 is 9 squared, and z squared is z squared. So we can factor this as the difference of squares. The first terms will be the square root of 16y squared. The square root of 16 is 4, the square root of y squared is y. And they are identical. For the last two terms, the square root of 81 is 9, the square root of z squared is z. So I have 9z in the front, 9z in the back. And again, one is plus, one is minus. Alright, moving right on. This one's slightly more complicated than the previous ones. You'll notice that 3b cubed is not a perfect square, neither is 27b. You might throw up your hands and say, this cannot be factored as a difference of squares. However, as we've said all along, the first thing we always want to check for is to see if we have a greatest common factor. 3 goes into 3 and 27. b goes into b cubed and b, so I'm going to factor out 3b. 3 divided by 3 leaves me with just a 1. b cubed divided by b leaves me with b squared. Then I have a minus. 27 divided by 3 is 9. b divided by b is nothing, or it's 1. Okay, so at this point, I can leave 3b alone, and I'll notice that what I have in parentheses is a difference of squares. And so I will factor it separately from the 3b. The square root of b squared is b. The square root of 9 is 3. One is plus, the other is minus, and we are done. Okay, perhaps it can be a little bit more confusing. So I might have a fourth power and a fourth power. All that matters here is that each is a perfect square. And that is the case. The square root of x to the fourth, and just to remind you that x to the fourth is x times x times x times x. The square root of this is just going to be x squared. So the first term is x squared, the first term over here is x squared, and similarly with y to the fourth. The square root of y to the fourth is y squared. One has to be a plus, one has to be a minus. Now, you may be ready to quit at this point. However, I do want to point out to you that one of our factors here is another difference of squares. This one is a sum of squares. It cannot be factored. It's prime, actually. but the second one can be factored. So I'm going to rewrite the prime factor, x squared plus y squared. And now I'm going to factor the other one. The square root of x squared is x. The square root of y squared is y. So our second terms are y. One is plus, one is minus. We factor that completely. Okay, let's go to another ugly one. 4y to the fourth is a perfect square. So is 2500. But I don't expect you to know that off the top of your head. We can make this look easier if I factor out a GCF. If I pull out 4, that's going to leave me with y to the fourth minus 625. You may not like this any better. For that, I apologize. Okay, we're going to leave the 4 alone. The square root of y to the fourth is y squared. And at some point, you might learn that the square root of 625 is 25. Make this guy plus, this guy minus. And again, we're in a similar situation as we were in the previous problem. This guy's just a constant. This one is prime. We cannot factor a sum of squares, but we can factor a difference of squares. So I'm going to go down one more line. Again, the sum of squares is prime. I can factor the difference of squares. The square root of y squared is y. The square root of 25 is 5. One is plus, one is minus. And we have completely factored this binomial. Okay, this one looks very ugly. It has 4 terms. I'm thinking I'm going to factor by grouping. But I remember that the very first thing I always do is to pull out a GCF if I can. And in this situation, 6 will come out. I can factor 6 out of every single term. It should make my math a lot easier. Now, I'm going to factor by grouping. That's what I typically do when I have 4 terms. We're going to have to keep up with the 6, which is going to be annoying. I'm going to use brackets here. Pull out an x squared from the first 2 terms. And I can pull out negative 4 from the second 2 terms. Okay, once I do that, we've got the 6. One of my terms is x plus 5. And the other term is x squared minus 4. You might think we're done, but of course this is a lesson on the difference of factoring by the difference of squares. And so hopefully you recognize that x squared minus 4 is a difference of squares. The square root of x squared is x. The square root of 4 is 2. One is plus, one is minus. We've completely factored that. Okay, we're almost done here. We want to solve this by factoring. So we're going from just factoring to actually solving an equation. Because these are quadratic equations, we always solve them by factoring. We want to set up equal to 0. That's very important. Okay, in this situation, q squared is a perfect square, and 4/25 is a perfect square. I know you don't like fractions, but 4 is a perfect square and 25 is a perfect square, so we should be good to go here. All right, we're going to factor the left side. We know the right side is equal to 0. The square root of q squared is q. The square root of 4 is 2. And the square root of 25 is 5. One is plus, the other is minus. Now, I have something times another thing is equal to 0. So I know that one of these two is equal to 0. Either q plus 2/5 is equal to 0, or maybe it's q minus 2/5 is equal to 0. In the situation on the left, I subtract 2/5 from both sides. The one on the right, I add 2/5 to both sides. So the way I'd write this is q is equal to plus or minus 2/5. That's 2 different answers. It could be positive 2/5 or negative 2/5. Okay, to solve the second one here, first I need to solve for 0. So I'm going to subtract 3y from both sides. Now, neither of these are square numbers, but I can take out a GCF. 3 goes into both, and y goes into both. Once I take out the 3, I'm left with 16y squared up front, and negative 1 in the back. Okay, we can factor this farther, 3y. 16y squared is a perfect square, as is 1. This is a difference of squares. The square root of 16y squared is 4y. And the square root of 1 is 1. 1 is plus, 1 is minus. Okay, finally, we have to figure out which one of our 1, 2, 3 factors is equal to 0. Maybe it's 3y. Or maybe it's 4y plus 1. Or maybe it's 4y minus 1. We solve each of these separately. The first one I'm going to divide by 3. The second one I'm going to subtract 1 and divide by 4. And the third one I'll add 1 and divide by 4. So I've got 3 different possible answers for y in this situation. I can write it all together. Y equals 0, or maybe y is positive or negative 1/4. Okay. Last example. A square with side length x is cut out of the triangle shown below. Write an equation in terms of x that represents the area of the figure after the square is removed. Well, first we're starting with a triangle, and I hope you remember that the area of a triangle is 1/2 base times height. In this situation, the base of the triangle is 8, and the height of the triangle is 16. Okay, just simple computation here. The area of this triangle is 64. They don't ask for the area of the triangle, however, they ask for the area of the figure after we remove this square. I hope that you can see that a square that's x times x, its area is x squared. And therefore, the area of our figure, A, is going to be the area of the whole triangle, 64, minus the area of the square, which is x squared. Part B says, what value of x will result in a figure that is 3/4 of the area of the original triangle? 3/4 of the area of the original triangle. Well, the original triangle is 64 square units. And so 3/4 of 64 is 48. We want to know how big of a square do I have to cut out to leave me with 48 square units. Well, I'm going to set this, our area, equal to this, the formula we have for area. So the area we want is 48, and we'll take the original triangle, 64, and subtract x squared. So to solve this, I'm going to add x squared to both sides. I like my x squared to be positive. And then let's subtract 64 from both sides. When I do the math, that leaves me with, on the left side, x squared minus 16 equals 0. I'm trying to solve for x, and I hope you can see that I have a difference of squares, so I'm going to solve this by factoring. The square root of x squared is x. The square root of 16 is 4. One's plus, one's minus. So x can either be positive 4, or maybe it's negative 4. Now, x represents the length of a side of a square. You can't have a negative length, and therefore x must be our positive one. X is equal to 4.